last part of your whole O-level syllabus, you have the condensation polymerization. Okay, so monomers are covalently joined together to form a polymer, and then in addition polymerization, there is no loss of any atoms. Okay, but in condensation polymerization, there is a loss of small molecule, usually water. Water condense out from H2O, that's why we say it's condensation polymerization. Okay, two monomers with functional group at the end of each molecule, and they are usually of different functional group, usually. Okay, so two synthetic polymers made from condensation polymerization. These two is memory work, often they test you. So we have the terylene, which is a polyester. Ester, remember your C double bond O, single bond O, and a nylon, which is your polyamide. Okay, nylon polyamide will look something like this. C double bond O, single bond N and H. Okay, this one later we will see. Okay, so these two are like your cloth that you use to make clothes. Okay, so terylene or your polyester, because it contains a large amount of ester links. This is a man-made fiber used to make clothes. So the two monomers used are a dicarboxylic acid and a diol. Remember, just now to form esters, you need a carboxylic acid and an alcohol, right? But to keep forming the esters in a long chain, you will need what we call a dicarboxylic acid and a diol. So dicarboxylic acid just means there's COOH on either side, and diol means there's OH on either side. Your functional group is found at the end of your molecule. Okay, so a polyester, how is it formed? Via condensation. So same idea, when we form esters, the OH from your carboxyl and the H from your hydroxyl is removed. Okay, so when you remove the OH and H, this carbon is going to join immediately directly to the O. So you have a C double bond O, this is bond to this O immediately. You have a ester linkage. And because your functional group is found at this end and your this end as well, this process can keep repeating. So the OH from here, you know the H from the OH, the H from the alcohol at the right end can go and join to another carboxylic acid, right? So the OH from your carboxylic acid will be removed. So same thing, this one is removed, the whole thing, they will join together out again. And you will have a ester again, C double bond O, single bond O. Okay, so the whole thing will keep repeating, and then you will have N water that is being condensed out, depending on how many linkage you have. One linkage, one water. One linkage, one water. Okay, so this whole thing is known as your polyester. Okay, this whole thing is known as your polyester. We also call it the terylene. Okay, this box over here, it doesn't matter. It can be X number of carbon atoms. This box over here can be 10 carbon atoms plus your hydrogen. Okay, it doesn't matter what's inside. It only matters that it forms the ester link. Okay, nylon is what we call your polyamide. Okay, so polyamide, we have a lot of amide linkage. So your amide linkage will look something like this. C double bond O, single bond N, single bond H. So amide comes from the word amino. Amino is actually your NH2 group. Okay, so nylon is used to make fishing lines, parachutes, sleeping bag, climbing ropes. This is good to know. Okay, so same thing, the monomers that are used, right, is your dicarboxylic acid and diamine. So you have NH2 group on the ends. Okay, and because it is a condensation reaction, your dicarboxylic acid, the OH is removed, and the H, instead of H removed from your alcohol, now I remove the H from your amine. Okay, so if these two are being removed, so likewise your carbon, this one will join immediately to the N. So you will have a C double bond O single bond NH amide group. Okay, so you have an amide group, and then your next molecule at the end, because you still have a amine group over here, the NH2 group, H will be lost, and then you should join to your next carboxylic acid, the OH will be lost. So join these two up again, the N goes directly to the C, you have another amide linkage over here. Okay, so this one will form your polyamide. And likewise, how many amide linkage will result in how many water that is being lost. Okay, so from this picture, right, what is your monomer? Your monomers are this one and this one. Your dicarboxylate and your diamine. Okay, this whole thing in this box over here is your repeating unit. Okay, so terylene, you have your two monomers, dicarboxylic acid, diol. If I want to draw the polymer, right, I remove the OH, I remove the H, join the line up together, you get this C, immediately go and join to the O. So this C double bond, this C double bond O, right, is joined to the O here. So this O is this O. And this O is immediately connected to the white box, connected to the OH. But this H, right, at the end, this one will be lost again. So that's why when I draw your polymer, this one is just a line, and then put in the bracket N. Okay, so what is your repeating unit? Whatever that is inside the brackets. Okay, so this is your repeating unit. And your nylon monomer, you have a dicarboxylic acid and you have a diamine. Okay, what is going to happen? OH is lost, H is lost. Join it up together. Your C joins to the N directly. So C double bond O is this C double bond O. This one will go and join to the N immediately. So join to the NH. Okay, join to your NH, and your NH joins to the white box immediately. Right, this H will be lost, so don't write. This OH will be lost. Don't write. This is your polymer, bracket N, and your monomer is whatever that's inside the brackets. Okay, problems with synthetic plastic. Addition polymerization and condensation polymerization produces cloth and plastic. Okay, advantages: they are cheap, easy to mold into shape, they are tough, waterproof, durable, etc. The main disadvantage is it is non-biodegradable, so it cannot be broken down into simpler substance. Millions of years later, it will still be around on Earth. So this leads to land pollution. And if you try to burn it, it will produce poisonous gas. Okay, so it will cause poisonous gas, carbon monoxide, it will produce soot, cause haze, etc. Okay, PVC, if you burn it, it will also produce HCl. So this is your chloroethene. Okay, the chloroethene, polychloroethene, right? It will produce HCl and it will cause all these problems.